we will be looking at the modulus functions, and I'll be showing you how to draw a couple of graphs when the modulus function is applied, and also just a couple of quick examples and some exam questions which may be a bit more tricky. So first of all, what is the modulus function? Well, it has the effect of changing a value into its magnitude. Okay, so it's like the absolute value, for example. So for example, if you have the absolute value of -2, well, this is just going to be equal to 2. This is an example of how the modulus function will work. You can see here on the page, there's two different versions. Y is the modulus of f of x, and y is f of the modulus of x, and they have slightly different effects, which we'll come to see later on. So let's just go through a couple of examples. So if we have a function such as 4x plus 2, and I'm asked, how do you find the modulus, or sorry, the f of -2? Well, first of all, you just simply plug it in, right? So we have f of -2, well, that's going to be equal to 4 times -2 plus 2, which will give us -6. So that's fairly simple. We should hopefully know how to do this. Now B asks us to find the modulus of f of -2. Well, it's the same thing as before. So we found earlier that f of -2, well, that's was equal to -6. But if we're asked to find the modulus of f of -2, that is in the effect of having to find the modulus of -6. And the modulus is like the absolute value, which means we change it into just 6. Okay? So this is an example of y, such as y is equal to the modulus of f of x. C is slightly different, so you can see here at C is asking us to find the f of the modulus of -2. So unlike B, where you put in -2 into the original function, we have to apply the modulus sign to this -2 first. So we know that the modulus of -2 is equal to 2. So we have to say that f of the modulus of -2, well, that's going to be equal to the f of 2. And now we can plug this 2 into our original function here. So that's going to give us 4 times 2 plus 2, which would give us 10. So you can see it's slightly different, the B and C examples. One of them is the modulus of the whole function. C is the modulus of the x values and then plugged into the function. So if I was to write C, that would be an example of y is equal to f of the modulus of x, like such. So you can see that's slightly different. Just be aware of how they differ. Let's just look at this function as well. Well, this is a quadratic function, okay? So first of all, I can just plot this first. So factorizing this, we get x plus 5, x minus 1. Okay, so we know it crosses at 1 and -5, and it's like a quadratic function, so it should look something like such. Where here is 1 and here is -5. Okay, so this is very simple, but sometimes we are asked, well, can you plot the graph of y of modulus of f of x? Okay, when we are asked to plot this graph, what we have to do is we have to reflect, okay, so reflect everything on the line y is equal to 0. And not everything though, but just the negative values. So in this case, we reflect all this bottom part up along the line y is equal to 0. So if we were to do that, well, that would look like something like this. Okay, where this is still -5 and this is still 1. So if we're asked to draw a graph of y as modulus of f of x, then we're reflecting on the y is 0, but only for the negative values. The positive values here and here, we just leave as b. What about if we were asked to draw the graph of y is equal to f of the modulus of x? As we've seen before, this is slightly different. What this has the effect of doing is changing all the negative x values into the positive values, and therefore, if we were asked to draw this graph, then what we have to do is reflect along the line x is equal to 0. Okay, but once again, this is only for the positive values. So we draw the positive values, So we draw the positive values here. So it goes past it up to here. And then we reflect this part onto the negative side. So it has the effect of looking something like this. Okay. So this negative portion has now disappeared. We've only got the positive side, which has been reflected along the line x is equal to 0. Okay, so a quick recap. If we have y is modulus f of x, we reflect along the y is equal to 0 line. Only for the negative side, we move up to the positive section. And for y is f of modulus of x, we reflect the positive side, all of it, to the left hand side. Let's look at it for the sine and cosses. So sine x, we know simply that, well, that just looks something like this. Okay. Now if I was to draw y is equal to the modulus of f of x, okay, then that means we have to reflect along the line y is equal to 0, but it's only for the negative section, so it will look something like this. Sorry, like that, okay? So I'll draw again, so it looks something like such. Right, if I was to ask to draw y is the f of the modulus of x, well, once again, we have to reflect along the line x is equal to 0, but we reflect the x hand sides, the right hand side to the left hand side. So this right hand side portion will just still look exactly the same, like such. Okay, but if I was to draw to the negative section as well, well, it will look something like such. Okay, sorry about the drawing, but it will look something like that. Let's look at for cos x. Well, for cos x, I'm going to draw it from minus 360 to 360, so that's going to look something like this, like such. Once again, if I was asked to draw y is equal to the modulus of f of x, well, we know that has the effect of reflecting everything on the below the line y is equal to 0 into the positive section. So that means that all these sections here, they get reflected up, and so we'll have something, that looks like this on this side, and we also have the same scenario on the other side. If I was to draw y is equal to f of the modulus of x, once again, we reflect everything on the right hand side to the left hand side, but as you can see, this graph is actually symmetrical along the line what x is equal to 0. So it just wouldn't have any effect in this example. So it just still look like the cos x graph. Okay, let's try and find some solutions with this modulus. Okay, so we are given a function f of x, which is 2x minus 1, and we have to find when is the modulus of f of x equal to 5. So whenever we're dealt with these problems, it's always best to try and sketch the graph first. So once again, 2x minus 1, where it passes at minus 1, like this, and it's got a gradient of 2. But because it's the modulus of that, well, we have to reflect it along the line y is equal to 0. And so it will look something like this. Okay, so we don't need this portion of the graph here. Okay, so we're asked to find when is it equal to 5. So we can draw a straight line across when y is equal to 5, like such. As you can see, there's two intersection points here and here. Okay, so we can simply find, well, 2x minus 1 is equal to 5. Therefore, 2x is equal to 6, and so x is equal to 3. So this intersection point here is when x is equal to 3. However, we also have a negative value here as well. In order to do that, well, we know that this section of the graph here has been reflected or has been affected by this modulus. So what we do is make this f of x function, we turn it into a negative. So we say negative of the f of x, 2x minus 1, well, that's still going to be equal to 5. Which means that we have negative 2x plus 1 is equal to 5. Negative 2x is equal to 4, so x is equal to negative 2. Okay, so to find the solutions, we have to understand which part of the graph has been affected by the modulus function. If this side has been affected, so we change that into a negative of the f of x. The right hand side has not been affected, it's like the original one, so we keep it as the positive function. Let's look at another example. Okay, so we have two modulus functions, okay, but it's always, as we said before, always good to sketch the graph. So modulus of 5x plus 1 passes through 1, looks something like this. So this would be the y is equal to the modulus of 5x plus 1. Okay. The modulus of 3x, that's a straight line graph, so it will look something like this with this lower gradient and like such. So this would be the y is equal to the modulus of 3x. You can see here, there's two intersection points here and here. Okay, it's kind of small, but hopefully you can see. So we need to understand how to find it. Well, once again, it's very important to understand which part of the graph has been affected by this modulus. So if I was to look at this one here, this first intersection point here, well, the 5x plus 1, well, that's like from the original graph here. So that's just going to be 5x plus 1. However, as you can see, this 3x value has been affected by the modulus. Okay, because it's on this left-hand side. So that's going to be equal to the negative of 3x. Which will mean that 8x is equal to negative 1, and therefore x is equal to negative 1 over 8. Okay, what about this second intersection point? Well, this has the 5x plus 1 function. This has now been affected by the modulus. So we have to do a negative 5x plus 1. And that's equal to, well, it's still the left-hand side of this 3x one, so it's negative 3x. So we can have 5x plus 1 is equal to 3x, therefore 2x is equal to negative 1, so x is equal to negative a half. Okay, so that's why we always try and draw the graphs, so to see, has it been affected by this modulus functions. Okay, so the last two examples are some popular exam questions which they might give you. Okay, so they're saying find the value of k for which there are only two solutions for this equation here, and for a domain of x is being bigger than 0. So we always sketch this graph. Try and sketch it first. Right, 6 minus x, okay, and that's being affected by the modulus, so it looks something like this. However, we've got a domain here where x has to be bigger than 0, so we don't technically need this left-hand side, because we're only looking for x is bigger than 0. And they're asking what value does k have to take for there to be two solutions? We can see here k is just a straight line graph. So if we were to look at this graph, then it would have two solutions when k is this value here, okay, when y is equal to k. So we just need to have to find this value of k. Well, this is when x is equal to 0, so we can plug that into here. So if the function is 6 minus x, well, that's when x is equal to 0, so therefore f of 0 is 6. So it would have two solutions when y is equal to 6, or anything in between, below that as well. This will have two solutions as well. Okay, so anything below y being less than 6. However, it's not always the case, because in this scenario here, it doesn't intersect whatsoever. So there's going to be an upper limit as well, and that is when it's bigger than 0. Okay, so k is when it's bigger than 0, but it's when it's less than or equal to, because it can be equal to 6. Hopefully this was helpful. If you have any other questions, just comment below and we'll try and get back to you as soon as possible.